The third quantum number is called the magnetic quantum number. It gets the symbol M. And what this is going to tell us about our probability cloud is the orientation in three-dimensional space. So the shape in the XYZ plane. Right? The possible values now are another range of values from negative L to positive L. Once again, best seen with an example. So it's always going to be whole numbers. If L is 0, okay, well, negative 0 to positive 0, that doesn't exist. If L is 0, M is 0. Okay, if L equals 1, then M is the range of values from negative 1 to positive 1. So negative 1, 0, positive 1 are the possible values for M. So you can try one here. If L equals 2, then the possible values for the M quantum number are a range of values from negative 2 to positive 2. Okay, so basically what this means, okay, if we have L equals 0 or an s orbital that is a sphere, the M tells you how many possible ways you can orient a sphere in three-dimensional space. And the correct answer to that is just 1. Okay, if you have a sphere, it doesn't matter how you turn it or twist it on the XYZ plane, it's still a sphere, it still has that same shape, still same orientation. So for an s orbital, there's only one orientation. How many M values there are corresponds to how many orientations there can be in three-dimensional space. So the L quantum number of 1 corresponds to M quantum numbers of negative 1, 0, and positive 1, which means the dumbbell shapes can have 3 orientations in three-dimensional space. So the M values, once again, the numbers are physics notations, and the letters, in this case Px, Py, Pz, are the chemistry notation. And here is how you can arrange the p orbitals in three-dimensional space. You can put it on the x-axis, the y-axis, and the z-axis. So that is why there are 3 magnetic quantum numbers for the p orbitals. All right, for L equals 2, well, there would be 5 possible M numbers: negative 2, negative 1, 0, positive 1, and positive 2. These correspond to the 5 different orientations that these cloverleaf shapes can have in three-dimensional space. Once again, the numbers for M represent the physics notation, and the symbols represent the chemistry notation. And here are the 5 different orientations for the cloverleaf orbitals in three-dimensional space. So that's how they can arrange themselves on the XYZ plane. All right, the L equals 3, the F orbitals get really crazy. There's 7 different possible three-dimensional orientations. You can see those on the additional handout we gave you with these notes. So where do we find the magnetic quantum number on our quantum chart? They are under the L value in each section. So take a look. Underneath the L value, you will find the M values. We give you both the physics notation and the chemistry notation. The physics notation is the numbers, and the chemistry notation is the symbols or the letters. So for L equals 0, we got a symbol of just a dot, and then you can see the L equals 1, you got all the M numbers, and then Px, Py, Pz, and same with the L equals 2 and all of its magnetic quantum numbers, and then the F orbitals and all of their quantum numbers. We give you both the physics and the chemistry notation. The fourth and final quantum number is referred to as the spin quantum number. It gets the symbol S, and this tells us the energy state of the individual electron. A low energy state corresponds to a possible plus 1/2 value. That is the numerical value, so that's the physics notation. The chemistry notation is just an up arrow. Okay, then we have electrons that have a high energy spin, and these will get a physics notation for S of negative 1/2, and a chemistry notation is just represented with a down arrow. All right, so where do we find the spin quantum number on the chart? It's just the arrow in each of the boxes. So the spin quantum number is responsible for giving each electron its own identity. It's this electron that allows us to make sure every electron has its own set of 4 quantum numbers. So if you look at chromium here, number 24, it has an up arrow in the box. That means it has that electron, the 24th electron, has a spin of positive 1/2, or up arrow. And if you just go a couple down the table, if you look at cobalt here, the 27th electron has a down arrow, chemistry notation, or that would correspond to a negative 1/2 physics notation. So you can find the S quantum number just by looking in each of the boxes.